Welcome to another episode of the NLP Highlights podcast. Today we have Suchin Gururangan. Sachin is a researcher who specializes in socio-technical approaches for training LLMs. He just finished his PhD at University of Washington, so it's a very exciting time. And he's starting his next thing at the Llama team at Meta next week. So congrats on that. It's like you're at the center of the universe. Basically, everybody's looking forward to what Llama's going to be releasing next. So welcome to the podcast, Sachin.
Thank you so much. Thank you so much for having me. This is a really good time to do a podcast. I had this kind of week lull. So I'm really happy to be here.
So could you tell us a little bit about who is Sachin? Like I know you pretty well, but maybe other people don't.
My name is Suchin. I just finished my PhD at the University of Washington in NLP. I've been in the UW NLP community since around 2017. It's been a while. I started kind of doing my master's there and some kind of random professional master's sort of program that I kind of applied to at a whim, and got hooked into NLP research and was really embedded into not only UW, but also organizations like AI2 and Meta throughout my PhD. And been really lucky to kind of work with lots of really great people there. My research has broadly just been about kind of not only training really efficient language models, but and effective language models, but really understanding the relationships between their kind of downstream behavior and the data that they're exposed to, and during training. And my work has really tried to urge folks to think more about language variation in training data, think more about customization after training. And I really think that focusing on these aspects not only is desirable from like an ethical or responsible perspective, but as we've had a lot of success kind of showing that being careful about your data, it leads to really efficient scaling and lots of really cool new capabilities that I'm excited to talk about with you today.
Awesome. I want to dive in into the customization aspect and talk a lot about what do you mean by that, and why do we need it and how to achieve it at a large scale. But first I need to find an embarrassing thing about you. And one thing that comes to mind is that you're pretty bad at surfing. When we went surfing a few years ago, did you get any better?
Not really. For context, Waleed and I went to San Diego last year and for a surf weekend, and we both did pretty poorly. I might have hyped myself up a little bit, but Waleed, you didn't hype yourself up, so you kind of met expectations, I guess. I live in sunny SoCal, or have been for the past couple of years, and have not gotten better at surfing. But we'll see. I'm moving up to the Bay pretty soon, and I hear the surf's pretty good up there, so maybe I'll get better.
For fairness, you've been very busy building awesome things, which we're going to be talking about today. So it's okay. Hopefully, Llama team will give you some chance to still do some of that. So let's start by something that, what is the case today? How do we train language models today? And, what is wrong with that?
Yeah. And, the language models that are being deployed today are so incredible. There's so many things that we, when I started my PhD, we never thought would be possible to do with these models. And we're, it's really blowing me and lots of researchers away, right? And kind of the standard way that we train these systems is, some large corporation or some large collective pre-trains a transformer language model on some giant corpus of text. And then everyone else, downloads or fine-tunes the model towards some sort of task, or just prompts the model directly through some API. And this is pretty tried and true method. With my thesis is really showing, and one thing that I really argue is that the way that we scale into these massive data sets presents a lot of really important issues. there's everything from legal risks associated with training on all of the internet, basically. There's harmful behavior that these models are very prone to sort of reproducing after being exposed to certain dark parts of the internet. And there's an extreme cost to scaling into massive data sets. And I don't expect the scaling part of it to go away in the next few iterations of language models. I expect them to be trained on trillions and trillions of tokens of text, but we still have to contend with these sorts of trade-offs. Yeah.
So just to reiterate on the socio aspect, because I think like it's in the socio-technical approaches is what you're referring to, your methods. Let's like pick one specific example of like the ways in which the current way we're training language models are problematic. I want to invite you to like elaborate a bit on one of the slides in your thesis defense, where it was talking about this study that you did comparing, like correlating different school systems or different neighborhoods with the like how much does the language model approve of the like the school work that came out of it?
Yeah. So one of the big aspects of language model kind of data curation and training that I highlight is this fact that we tend to curate data for language models in a fashion that's called laissez-faire. And the idea there is that we want to train on as much data as possible on basically sourced from the internet. But as we scale, it becomes harder and harder to know what exactly is in our training data, right? And we have to make we have some criteria that we have for these corpora. We want them to not contain a lot of toxic language. We probably don't want a lot of ads there. We want to remove some maybe like the boilerplate sort of HTML content that we don't really want our language models to see. And so we apply these things called quality filters to the data, and these tend to be kind of either heuristically driven sort of systems. Maybe you want to remove really short content in the training data or something like that. You can also apply classifiers, right, that are basically trained to identify some notion of like high quality content. And so this is a almost universal sort of procedure for curating the training data for large language models. And one thing that we dig into in our thesis is this idea that when you apply these sorts of quality filters, you introduce these sort of implicit ideologies of what it means to be high quality text, right? And this goes back to like, there's been, since the 80s, there's been lots of work on how humans kind of decipher what it means to have good or bad language and how that can lead to a lot of stigmatization in the community. Bias in the legal system, the educational system, things like that. In the context here, what we argue is that these ideologies, which we're not very transparent about, can actually lead to lots of unintended consequences about whose data is actually in this training data, right? And so the way we kind of empirically kind of analyze this is by curating this new data set of high school newspapers from across the United States. And we basically match those newspapers and the articles within them to demographic information around the school and the county and the zip code that kind of the school resides in. And we basically reproduced this quality filter that was used to curate the GPT-3 training corpus. And then we apply that quality filter to this data set of high school newspapers. And the basic question is like, who gets filtered out, who gets included, right?
Can I clarify something here? You mentioned a filter used for GPT-4, but I thought the GPT-4 filter is private. How do you know?
Oh, sorry, I said the GPT-3 quality filter, which is actually, they published the implementation details of that quality filter, and so we reproduced it internally.
Got it, perfect. And the high school newspapers are written by students primarily, I'm assuming?
Yeah, exactly. So there's all student-written papers, and they'll cover everything, they'll cover everything from like, sports articles to like, general news in the world to, campus announcements and, certain school-related things. So it covers a pretty broad range of topics, but they are written by students.
I imagine it's a lot more transparent and anti-political compared to the high-profile newspaper agencies that we actually read every day.
Actually, like this actually goes to one of the takeaways of the work is, one thing that we find is that the quality scores that you get for an article are really well correlated with how well resourced the school is. And it's also very correlated with like how similar the articles are to like Newswire or like the New York Times or Wall Street Journal articles, right? And one thing we argue is that like schools that are more resourced and they have much more kind of capability to provide an environment in which a student can actually like practice being a journalist, right, and write about the topics of the world and current events that you might actually see on the New York Times, those tend to have more high quality content according to this quality filter, right? So there's sort of a relationship between how similar the content is to Newswire and thus like how well resourced the school is.
Right. So the implication here is that we are maybe inadvertently suppressing the information that is very real and very valid and very high quality, but it does not represent, like the more mainstream voices in the society.
Yeah. So I guess put succinctly, like we basically argue that these quality filters, based on the notions of quality that we kind of imbue when we train those quality filters, they tend to overrepresent the authors from very hegemonic social positions. Authors that tend to be in urban areas, authors that tend to be in wealthy parts of the United States, authors that are in zip codes that are very well educated, and it tends to implicitly not favor content from rural areas, from areas that are less resourced. So what we argue is that there's always subjectivity when you're curating data. And because we're not transparent, and it's very difficult to be transparent about kind of what decisions were made when you're curating the data at scale, you're going to have all these sorts of unintended consequences. So kind of stepping back a bit, with all these like amazing things that these models are able to do, there's kind of this broad perception that these models are in some sense like general purpose, right? And they're kind of all encompassing. They might be all powerful. You might think that, oh, they can do basically anything. And what we argue is in this work is that there is no such thing as a general purpose model. There's no such thing as a general purpose corpus, because a curator always has some ideology of like, for example, what it means to be high quality, or what text should be included and what text should not, right? And that necessarily means that this data set is constrained in some way, right? And thus the model is constrained in some way.
So thank you for highlighting that. I love that line of work because it emphasizes a much broader, like pattern I've seen in science in general, where like the people who do the work are empowered, are privileged to make choices, and those choices reflect their biases, which is a little bit inevitable. But I guess it sounds like an existential crisis. Like, okay, we cannot fix it. So what did you do?
Yeah. So what I've always argued is that customization and adaptation and flexibility is something that we should really focus on with these models, because it's going to be impossible to build a general model that is, a one-size-fits-all sort of system for everyone. So let's instead assume that, okay, we'll get to a really good checkpoint, with the initial pre-training phase that, Meta or OpenAI might do. But like afterwards, we really need ways to kind of customize the model to anyone's use case, right? And so a lot of my work has really focused on how do we do that really efficiently? How do we think about language variation and domains in training data, and apply boundaries between kind of different data sets and language variations to do this customization more effectively. So we've worked on a lot of different areas of work in that direction. I think that the most popular thing that we worked on is this idea of adaptive pre-training. And basically, it's really simple. It's this idea of just continuing to pre-train your model on a downstream corpus, right? And the technique is very simple, but there's so many really, really interesting questions there around, what does it mean to be a domain? What does it mean to how do you customize things efficiently? And yeah, that's kind of a second big thrust of the thesis.
What would be a surprising result that you got in this line of work? I know you've written so many papers. I probably read only a quarter of them. I apologize, but I'm really impressed by the impact that the work that you did have achieved, and congrats on that. And with it often comes a surprising result. So what is one of the surprising results in your adaptive pre-training methods?
Yeah, so I think the coolest thing that I found is this idea of that the domains and language variation comprise some sort of spectrum of different granularities, right? So this basically what we found is that to get the best performance on a particular task, you don't just want to adapt to the task. You want to do this sort of multi-stage approach where you first adapt to the domain or the sort of variation of language that this task might reside in, and then kind of start fine-tuning on more and more specific data related to the task. And I've been really excited about this sort of spectrum idea when it comes to organizing data. And in work since then, we've kind of adapted this idea to time, where to get the best performance of a model on a specific time period, you want to adapt to the year that the model that the data sort of locates to, then the month that the data locates to, then the day. We've adapted this idea to languages, right, in the multilingual setting, where maybe you first adapt a model to a language family, and then specific languages, then maybe a domain within the language, right? So yeah, I think this adaptive pre-training step this work was really cool in that it kind of pushed me to think about how data is organized in this kind of structured way, and how you can make use of that to just get better performance.
And that is aligned with your next role at Llama, but most people are not there. So how can the average research team that does not have the insane resources that you guys have in Llama benefit from these results? Do you and let me clarify actually a question, clarification you mentioned before, customization and adaptation. Are you referring to them as kind of different things or synonyms when you mention customization and adaptation?
Oh, I think of them as analogous terms. I think the way that you can adapt is different, but the goal is basically to customize the model towards a specific behavior.
So I would like to draw a line between the kind of adaptation that one needs to be in a high resource environment, that basically the team that has the capacity to train, to pre-train a model from scratch, or something like that, to compare to methods that are useful for the rest of us. So I want to actually zero in more on the latter, because I think that's relevant to more people. Would you elaborate on what did you find to be useful for the latter?
Yeah, totally. So yeah, I mean the natural kind of thing to do in a low resource setting is something like using parameter efficient techniques, right? You could use adapters or just fine tune parts of the model, maybe just to feed forward layers of a transformer or something like that towards your task. This does depend on having access to model parameters, and with a lot of systems, you're not really able to do that. There's more black box techniques for adapting models to new distributions using retrieval. So we've kind of worked on approaches where you are basically adapt the model to a new behavior by retrieving sort of relevant examples for your downstream task or your domain, and you stick it into the prompt or as additional demonstrations when you're querying the model. One thing I've been excited about in terms of cheap adaptation techniques is this idea of interpolating between models and to basically induce new behaviors. So we had this work last year around something we call task arithmetic. And basically the idea there is when you want to adapt your model to a particular behavior, you can fine tune the model towards a particular behavior. Let's make it a little more concrete. Like, let's say I want to make my model like less toxic. So maybe in this task arithmetic setting, you can basically fine tune the model towards non-toxic text, and then you subtract the weights of your fine-tuned model from your pre-trained model. Okay, and you get something we call a task vector. Right, this is basically a direction and movement towards like non-toxic behavior. And what we find is that you can actually, with this task vector, you can basically you can merge or compose or interpolate that task vector with other task vectors, right? So let's say now I want to create a model that is, a non-toxic like chat model, right? What I would do is I have my non-toxic task vector that I've already retrieved. Then I also fine tune a model towards chat, right? And then I do the same subtraction and I get like a chat vector. And what we find is that you can interpolate these two vectors together, you can get a model that actually is both non-toxic and can chat. Wow. And so like kind of you get these sort of multitasking behaviors by like merging these sorts of task vectors together. And the really cool thing there is it's really expensive to pre-train, right? And to do continued pre-training. And when you do continued pre-training, you had these sort of catastrophic forgetting effects, right? Where you forget like what you've previously seen. In this sort of task vector modular sort of framework, you can basically compose whatever task vector you want towards the behavior that you desire. And you still have other task vectors lying around so that you can kind of modulate your model's behavior as you want after training. And so, yeah, so like these sorts of modular ways of adapting behavior, I think is really cool, and I think can lower the barrier for adapting to or customizing to new behaviors.
So that's a little bit mind-blowing that it works. I mean, it sounds like a cool idea, but I would say, yeah, try it. But it actually works, and I know when you say it works, you've done the due diligence. I guess one thing that is unclear to me is like, what is the scale, or how do you specify this vector? Is it a vector that includes all the dimensions in the entire model parameter space, or is it something that has to do with the input vector, or something that has to do with the output vector?
Correct. Yeah. So it's the former. So in the works we've done so far, the vector is basically the direction of movement for all parameters of the model towards this particular data set or this behavior. But presumably with like, I don't know, with like LoRa or other sort of parameter efficient techniques, you could do similar stuff in sort of a low rank regime. Maybe it's more efficient, but we haven't explored that yet.
Cool. Which also means that if you're using all the parameters, you can also probably do some filtering, or like only optimize a subset of them, and you get a bit of that effect. That's fantastic that it works. I'm a little bit surprising.
Yeah, it's really cool. Like we've explored this kind of idea for not only tasks but like adapting over time, and you can basically we've done some like wild things of like extrapolating to new time periods by interpolating these sorts of what we call time vectors that are specialized to different time periods. We've kind of looked at it, the same idea with respect to like domain specific models that are maybe specialized to biomedical papers and like computer science papers or like news, and you can basically compose these sorts of vectors together to compose the behaviors that you would expect from models that are specialized to each domain.
Well, what is the failure story here? Is there anything that you tried that didn't work, like in terms of adaptation with this method?
Yeah, so basically one thing that we found is that like model merging, it basically approximates ensembling models in output space, but it doesn't work as well in terms of the performance. So like if I really cared about like how low my perplexity is on documents that like are in our like non-toxic chat example are like chats that are non-toxic, like a merger of those, like I'm better off like having models that are specialized to both kind of non-toxic text and chat, and then having them active during inference, and then composing their outputs at inference time, rather than doing the sort of merge. It's more expensive to do the ensembling, but it actually works a lot better. So I think it's kind of a neat trick to kind of make inference cheaper when you have like lots of these different vectors or models around that you want to kind of merge together to get a very specific behavior. But there's still a lot of work to be done to like figure out how to merge properly so that you can bridge this gap between like ensembling the models and actually merging them.
So to clarify, the thing that didn't work is still like using the task vectors for the toxicity, or is that what you're saying?
I'm saying in broadly speaking, like if I was trying to merge two models or two task vectors or whatever they're, I'm much better off actually having both of those task vectors or models like online and then ensembling them at inference time,
Gotcha.
rather than kind of collapsing them into like a single vector or model that I then deploy.
Makes sense. Thank you. So I want to retract. Kind of like you, like accidentally give me like a map to like yes no questions. Are you somebody who's able to pre-train from scratch? Yes, then you do that. Don't stop pre-training. Like that, your work has shown that it's effective. But you also mentioned catastrophic forgetting as a problem there. Well, how do you deal with it in your work on that?
Yeah, so for catastrophic forgetting, it's a hard issue, and I think part of it depends on like us defining like what do we want to use these models for, right? Because there's no free lunch, right? Like if I fine tune a model to more specialized text, I'm going to do worse on like other distributions of text. But if you want a model that does lots of different things, one thing we found to be really effective is this idea of parameter expansion. So this idea of like basically growing your model with more parameters that are specialized to different distributions of text, and then like either ensembling or merging them at inference time when you need to, right? So for example, if I want a model that does it does well at both biomedical papers and can also do autocomplete on like news or whatever, then I'm better off having parameters that are specialized to both of those different domains, keeping them active, and then ensembling at inference time, or maybe merging those parameters when I need to, rather than having a single model that can kind of do both. So in a lot of works, we've kind of explored this sort of mixture of experts sort of paradigm for creating these sort of multi-domain systems. And I think that's a really exciting area of work that I'm hoping I can kind of continue pursuing in the future. In terms of the cost to actually do these sorts of experiments, I think obviously training at scale is always really difficult. But one thing we've sort of envisioned with this kind of framework is, especially with the sort of parameter expansion idea, is that maybe in the future, like instead of there being one giant dense model that like everyone has access to, we actually have lots of tiny, maybe specialized expert models that are fine-tuned to different behaviors or tasks or domains based on everyone's sort of individual interests that are kind of shared among the community, right? And it's more decentralized. And the hope there is that the training of an individual expert model is not as expensive as training from scratch. And you can kind of benefit from the compute and training that other people have done on their own expert models, and maybe merge or ensemble them with your, with the expert that you've trained to get better performance on your task. So I'm hoping that like with a more collective or community sort of language model, the costs of actually doing pre-training and continuing to pre-train on new text will actually be much lower than it is today.
So isn't this already what we have in Hugging Face, for example? You'll find a ton of different models that were adapted from Llama or another open source model. Is this already kind of like happening? I know you're like in your thesis, you're advocating for a specific way of doing that, but I mean, from what you're describing, like what do you mean? What you mean by decentralized large language models? It sounds like it's already happening in some capacity, and you're encouraging the community to go further in that direction.
Yeah, I totally agree. I think Hugging Face has been like a really great boon in this direction. They've built a great platform for model sharing and this sort of collaboration. I think there could be a lot more structure around that system, where mostly if you look at what is being, we've done this analysis actually, like if you look at what's being uploaded to Hugging Face and actually shared, they tend to be really tiny models that are trained on very specific tasks that may not be broadly useful. Having a system of kind of sharing models of a variety of different sizes and with broad sets of tasks that people care about, and having this ability to maybe like, if I have a particular data set in mind, I upload the data set and the server just returns to me the best sets of experts or the best language model or merger of experts that are optimized for my particular data set. Like that sort of system is something that I think would be really, really cool.
Great. I hope some of the people who are listening to this are like looking for their next project and like just jump on it.
Yeah. And one other thing, and one other thing that I've been really excited about with respect to decentralization is for users to have much stronger control over the data coverage of their model, right? Right now, even if I download a model on Hugging Face, I don't actually know what it's been trained on. And I don't know, I don't know exactly what the behavior of that model is going to be at test time. And one thing I've been really excited about is this idea of like a user being able to shape the data coverage of a language model after training, right? And this kind of brings me to some work that we recently published called Silo, which is a work that is really trying to build those capabilities into these systems through this sort of decentralization.
Could you tell us more about Silo? I do remember that slide, but I wouldn't be able to articulate it myself. So would you mind elaborating a bit?
Yeah, totally. So the standard way that people train models on data is, as I mentioned, laissez-faire. It is also dense, right? So basically we update all the model parameters with respect to all of that data, right? And we tend to scale pretty indiscriminately on web crawl, right? And the thing we were interested in this work was this idea that there's lots of legal risks, right, associated with training on copyrighted data. And these things are being sorted out in the courts right now. We'll see what happens. But we really need ways for me as a data owner to be able to say, hey, I don't want this model to know my website anymore, and for whatever reason, and the model should forget it, right? But we have no way of actually guaranteeing that sort of behavior without actually retraining that model from scratch. And this, I think, comes back to this idea of like centralized laissez-faire kind of methods of training, right? Like there's no way for me as a data owner to kind of shape the data coverage of the model after training, right? And this gets even more important if you're like New York Times or another publishing organization that wants to remove all of your content from GPT-4 or Llama, right? There's no way for you to do that without the model, being retrained from scratch. So what we actually propose is, what if you train a model on data that we broadly consider to be low risk, right? And there's lots of different definitions of it. This is another kind of subjective curation criteria, right? What we consider in the work to be low risk are permissively licensed text that has like, that is in the public domain or has a permissive software license on it. What if you pre-train the model only on that data, and then you scale into like copyrighted news, common crawl, private content on the internet, private health records, like whatever we feel to be useful to generalize into at inference time through non-parametric data stores. So non-parametric data stores are basically just collections or representations of this sort of text that we consider to be high risk that we retrieve at inference time, and we don't actually train model parameters on it. Okay, so you can retrieve from the data store through lots of different ways. Like you can retrieve these representations and stick it into like the context of the prompt and just continue prompting the model. or there are slightly more involved kind of versions of this. KNLM is another kind of popular way of doing it. But anyway, so basically we're trying to see if you trained in this more careful way, where you only trained on like permissive text and then like scaled into everything else through retrieval, can you actually build a good language model? Like, is it as good as like the densely trained laissez-faire models that we are currently using? And the answer is that, like, in terms of kind of perplexity on like held out data sets, as well as like few shot sort of task performance, you can actually do really well. Like, you actually get very competitive results with with a laissez-faire approach. But there are some limitations. It comes at a cost, right? You have to do this sort of retrieval step and sort of similarity search at inference time, so that kind of slows down inference a lot. I'm really excited about this sort of general idea because I think it can provide a lot of really cool features, right? If I'm New York Times and I want my data to be removed from the model, I can basically just remove my data from the data store, and the model, because the parameters have never seen the New York Times articles, like, it has verifiably forgotten New York Times, right? So as a user, I can opt out from the model. In the future, maybe we could pay data owners for using their content at inference time, right? So because basically the way the inference works, you always have to retrieve content from the data store before actually making the prediction. So I can say, hey, to predict this next token, I've used these K documents in my data store, right? And then I can pay the data owners for that prediction. So yeah, it's sort of lofty visions, but I feel like this kind of comes back to this idea of decentralization, right? And kind of empowering users to have this kind of power over the data coverage of the model.
I mean, I agree with everything you said, except the lofty vision piece, because now is the right time. Like, it's really like in the news. Everybody knows the case between OpenAI and the New York Times. It's just, it's as high stakes as it gets, which is a good time to solve it. And it sounds like you're, like, of course, you're not the only person who's working on this or have proposals for this, but at least you have hard evidence that this works. And yeah, I mean, hopefully somebody also, like, listening to this can, like, take action if, like, I don't know, like, is this something that you plan to continue working on, in the next few months?
I would love to. I think we did a lot of, there was success in the initial work. I think there's lots of really interesting things to do to build on this idea. So one idea is that we didn't really explore kind of generation quality with this sort of approach. And there are lots of really amazing things that, these dense models can do that we didn't really predict they were able to do, would be able to do. And I think there's lots of work to kind of show that the sort of retrieval augmented kind of language modeling approach can do these amazing things as well. So a lot of questions around evaluation. I think inference speed is probably the biggest issue. How do you speed up kind of inference when you have a data store that's like, a terabyte in size, right? That you have to do search over to kind of predict the next token, right? There's probably lots of simple things you can do to speed that up, but yeah, I feel like there's lots of low-hanging fruit to kind of explore, and it's something that I'm really excited about. I think how these court decisions end up playing out will govern a lot about kind of what we can actually train parameters on. And there might be a world where, like, actually, everything, all of Common Crawl is considered fair use, right? But even in that scenario, I think kind of segmenting training data and making sure you don't train parameters on certain texts is really useful, because, if I'm a enterprise and I want, my private company data to be used by the model but not kind of trained on, then this retrieval approach, I think, is still relevant.
And I mean, look, from my perspective, in the industry, it's actually quite popular already. Like, the RAG is the primary way products actually make meaningful use of large language models these days. There's like a lot of details of like how exactly to do it, and some are better than others, or some more efficient than others. Especially the retrieval component, I'd say, is something that is currently still underexplored. But there's a ton of work on it. That's the good news. So we talked about the type of people who are pre-training, like from scratch, and like don't start pre-training because they're forgetting what to do about it. But then we talked about people who don't, like you want to do very cheap tricks basically, and like I love that the task vectors and task arithmetic work. There's like this middle ground, which is actually a decent size of the population of developers and machine learning practitioners who are using large language models, which they have access to parameters.
Mhm.
They're not interested in pre-training from scratch. They may be doing some task-specific tuning, instruction tuning. Any advice or like learnings from your work for that kind of people?
Yeah, I think the main advice is that data is probably the key thing to focus on. And I think in terms of like curating more data, thinking very closely about the your notion of quality around that data, and yeah, thinking of creative ways of getting more text that is like in domain or like relevant for your task, right? And you can go a really, really long way by having lots of data that's like very specific to your task, and even just training, a few parameters on that, right? And I think in general, over the next few years, data is probably going to be king in the community. I think, the not only in terms of scaling to as much data as possible, but also just like thinking more closely about like what it means to be task relevant and domain relevant, and what are the right curriculums to train models on. And I think like the more careful we are about our data and like the more knowledge we have around the data that we're training on, the fewer resources we need to kind of do effective pre-training. So yeah, I think it's relevant for not just the small timer who has like, one GPU, but also the big players in the field that, have hundreds of thousands of H100s, right? So yeah, data is key.
Awesome. On that note, thank you so much, Sachin, for joining us today. Really enjoyed this conversation.
Thank you so much.